Hi everyone, I am Mrs.U.ELAYARANI from Mathematics Department, A.D.M. College for Women, Autonomous. Now we discuss about some basic structure of C programming and constants. C programming can be viewed as a group of building blocks called functions. A function is a subroutine that may include one or more statements designed to perform a specific task. To write a C program, we first create functions and then put them together. A C program may contain one or more sections, that is, documentation section, link section, definition section, global declaration section, and main of function section. The main of function section includes declaration part, executable part, and subprogram section. That is called subprogram section. That is called user-defined functions. A documentation section. The section consists of a set of command lines giving the name of the program. Link section provides instruction to the compiler to link functions from the system library. Definition section defines all symbolic constants. Global declaration sections are some variables that are used in more than one function. Such variables are called global variables and are declared in the global declaration section, that is outside of all the functions. Main of function section. Every C program must have one main of function section. This section contains two parts, that is declaration part and executable part. Declaration part consists of all the variables used in executable part, and declaration part consists of declare all the variables. There is at least one statement in the executable part. These two parts must appear between the opening and the closing braces. The program execution begins at the opening brace and ends at the closing brace. The closing brace of the main function section is the logical end of the programs. All the statements in declaration and the executable parts end with semicolon. Subprogram section. The subprogram section contains all the user-defined functions that are called in main function. These functions are generally placed immediately after the main function, although they may appear in any order. Next one is constants. Constants, variables, and data types. What is information? A programming language is designed to help process certain kinds of data consisting of numbers, characters, strings to provide useful output known as information. Program and syntax rules. The task of processing of data is accomplished by executing a sequence of precise instructions called a program. These instructions are formed using certain symbols and words according to some rigid rules known as syntax rules or grammar. Next one is character set. The characters in C are grouped into the following categories. There are, that is, 4 categories: letters, digits, special characters, and white spaces. The compiler ignores white spaces unless they are a part of a string constant. White spaces may be used to separate words but are prohibited between the characters of keywords and identifiers. Trigraph characters. Many non-English keyboards do not support all the characters. ANSYS introduces the concept of trigraph sequences to provide a way to enter certain characters that are not available on some keyboards. Each trigraph sequence consists of 3 characters, that is 2 question marks followed by another 1 character. These are the example of trigraph characters. Next one is C tokens. In a passage of text, individual words and the punctuation marks are called tokens. Similarly, program, the smallest individual units are known as C tokens. C has 6 types of tokens, namely keywords, identifiers, constants, strings, special symbols, and operators. Next one is keywords and identifiers. All the keywords have fixed meanings and these meanings cannot be changed. Keywords serve as basic building blocks for program statements. Some examples of keywords. Identifiers. Identifiers refer to the names of variables and arrays. These are user-defined names and consist of a sequence of letters and digits with the letter as a first character. Both uppercase and lowercase are permitted, although lowercase letters are commonly used. The underscore character is also permitted in identifiers. It is usually used as a link between two words in long identifiers. Next one is constant. Already know that constants in C refer to fixed values that do not change during the execution of a program. C supports several types of constants as illustrated in the following figure, that is constant, numeric constant, character constant. Numeric constant is divided into two types, integer constant and real constant. Character constant is divided into two categories, that is single character constants and string character constants. Integer constant. Integer constant refers to a sequence of digits. These namely decimal, octal and hexadecimal. Decimal is of digits 0 through 9. Preceded the below is the example of decimal integer constant. Embedded spaces, commas and non-digit characters are not permitted between digits, and these are the invalid examples of integer constants. Another one is octal integer constant. An octal integer constant consists of any combination of digits from the set 0 through 7 with a leading 0. Some examples of octal integer constant: hexadecimal integer constant, a sequence of digits preceded by 0x or 0x is considered as hexadecimal integer. They may also include alphabets A through F or A through F. The letters A through F represent the numbers 10 through 50. These are the example of hexadecimal constants. Real constants. Integer numbers are inadequate to represent quantities that vary continuously, such as distances, heights, temperatures, prices, and so on. These quantities are represented by numbers containing fractional parts like 17.548 are called real or floating point constants. Exponential notation. A real number may also be expressed in exponential or scientific notation. 215.65 may be written as 2.1565 E2 in exponential notation. E2 means 2. The general form is mantissa E exponent. The mantissa is either a real number expressed in integer. Single character constants. A single character constant or simply character enclosed within a pair of single quote marks. These following are the example of single character constants. The character constant 5 is not same as the number 5. String constants. A string constant is a sequence of characters enclosed in double quotes. The characters may be letters, number, special characters, and blank space. Hello is the example of string constant. Null character and escape sequence. Each string constant must end with special character /0, that is a null character. He places a /0, that is null character, at the end of every string constant. Printing characters and some other characters such as double quote or single quote, question mark and backslash require an escape sequence. A list of commonly used backslash character constant is given below. These are the examples of escape sequence. Next topic is variables. A variable is a data name that may be used to store a data value. Unlike constants that remain unchanged during the execution of a program, a variable may take different values at different times during the execution of a program. For example, average, height, total, counter1, class underscore string are the examples of variables. Variable names may consist of letters, digits, and the underscore character. Some rules for constructing variables. First one is they must begin with a letter. Some systems permit underscore as the first character. Second one is ANSI standard recognizes a length of 31 characters. However, The length should not be normally more than 8 characters, since only the first 8 characters are treated as significant by many compilers. Another one is uppercase and lowercase are significant. That is, the variable total is not the same as total or total. The variable name should not be a keyword. Final one is white spaces not allowed. Data types. C language is rich in its data types. Storage representation and machine instruction to handle constants differ from machine to machine. The variety of data types available allow the programmer to select the appropriate to the needs of the application as well as the machine. ANSI supports 4 classes of data types, that is, primary or fundamental data types, user-defined data types, derived data types, and final one is empty data set. All C compilers support 4 fundamental data types, namely integer, character, floating point, and double precision floating point. Many of them also offer extended data types such as long-int and long double. These are the data types and its range values. First one is character. The range value of character is -128 to 127. And the data type of integer range value is -32 768 to 32767. And float 3.4 e power -38 to 3.4 e power plus 38. And double is 1.7 e power -308 to 1.7 e power plus 308. Integer types. C has 3 classes of integer storage, namely shortint, int, and longint, in both signed and unsigned forms. We declare long and unsigned integers to increase the range of values. The use of qualifier signed on integers is optional because the default declaration assumes a signed number. Floating point types. Floating point or real number are stored in 32 bits with 6 digits of precision. Floating point numbers are defined in C by the keyword float. When the accuracy provided by a float number is not sufficient, the type double can be used to define the number. A double data type number uses 64 bits, giving a precision of 14 digits. These are known as a double precision number. Another one is character type. A single character can be defined as a character type data. Characters are usually stored in 8 bits, that is 1 byte of internal storage. The qualifier signed or unsigned may be explicitly applied to character, while unsigned characters have values between 0 and 255. Signed characters have values from -128 to 127. Declaration of variables. After designing suitable variable names, we must declare them to the compiler. Declaration does 2 things. It tells the compiler what the variable name is. It specifies that what types of data the variable will hold. The declaration of variables must be done for they are used in the program. Primary declaration. A variable can be used to store a value of any data type. That is, the name has nothing to do with its type. The syntax for declaring a variable is as follows. Data type, variable 1, variable 2, etc. variable n. That is, v1, v2, etc. vn are the names of variables. Variables are separated by commas. Their declarations are int count, int number, total, double ratio. Int and double are the keywords to represent integer type and real type data values respectively. Another one is user-defined type declaration. C supports a feature known as type definition that allows users to define an identifier that would represent an existing data type. The user-defined data type identifier can later be used to declare variables. It takes the general form typedef type identifier. Type refers to an existing data type and identifier refers to the new name given to the data type. The existing data type may belong to any class of type, including the user-defined ones. Remember that the new type is new only in name, but not the data type. Typedef cannot create a new type. Examples are typedef int units and typedef float marks. Here, unit symbolizes int and the mark symbolizes float. Declaration of storage class. The variable m, which has been declared before the main, is called a global variable. It can be used all the functions in the program. It need not be declared in other functions. A global variable is also known as an external variable. Local variables are visible and meaningful only inside the functions in which they are declared. They are not known to the other function. How to assigning values to the variables? Variables are created for use in program statements such as, for example, the program statement is value which is equal to amount plus in rate into amount, while year less than or equal to period, year equal to year plus 1. In the first statement, the numeric value stored in variable in rate is multiplied by the value stored in amount and the product is added to amount. The result is stored in the variable value. During assignment operation, C converts the type of value on the right hand side to the type on the left. This may involve truncation. When real value is converted into an integer, it is also possible to assign a value to a variable at the time the variable is declared. This takes the following form: data type, variable name which is equal to constant. Reading data from keyword. Another way of giving values to variables is to input data through keyboard using the scanf function. It is a general input function available in C and is very similar in concept to the printf function. The general format of scanf is as follows, that is scanf control string, ampersand variable 1, ampersand variable 2, etc. Defining symbolic constant. These constants may appear repeatedly in a number of places in the program. For example, such a constant is 3.142, representing the value of the mathematical constant pi. We face two problems in the subsequent use of such programs. First one is problem in modification of the program and second one is problem in understanding the program. Modifiability. We may like to change the value of pi from 3.1422 to 3.14159 to improve the accuracy of calculation or the number 50 to 100 to process the test results of another class. Understandability. Assignment of such constants to a symbolic name free us from these problems. For example, use the name strength to define the number of students and pass mark to define the pass marks required in subjects. Hash defines symbolic name value of constant. Symbolic names are sometimes called as constant identifiers. Since the symbolic names are constant, they do not appear in declarations. The following rules apply to a hash defined statement which define a symbolic constant. First one is symbolic names have the same form as variable names. Second one, no blank space between the pound sign and the word defined as permitted. Third one is hash must be the first character in the line. Fourth one is a blank space is required between hash defined and the symbolic name and between the symbolic name and the constant. Fifth one is hash defined statement must not end with a semicolon. Sixth one, after definition, the symbolic name should not be assigned any other value within the program by using an assignment statement. For example, strength equal to 200 is illegal. Seventh one is symbolic names are not declared for data types. Its data type depends on the type of constant. Final one is hash defined statements may appear anywhere in the program, but before it is referred in the program. Thank you.